Hello and welcome. Today I'm going to be working on a rather nondescript Philips CD player. I don't know what's wrong with it. I just took the lid off, which I thought was held in my Phillips screws. It's actually Torx screws. And then I had to struggle with getting the lid off because it was all hung up here. So I'm already off to kind of like a bad start. All I know about this thing is it doesn't work. This is really like all 100% plastic. Let me go ahead and turn this thing on, see what happens. Okay, we get a display. That's a positive sign. Let's see if we can open the tray. That would be the next step. Okay, tray's going good. In fact, if I look down here, there should be a belt there somewhere. Well, I'd have to focus in closer. Let's put a CD in, see what happens then. Okay, then I heard something want to spin, and then we get the E, which is error. Now I can't see what's going on with the laser here because of this clamper is in the way, so I'm going to go ahead and pull this clamper. So I've already been playing around with this here, and I think what I have to do is I got to remove this spring here. I don't know if I can do that by hand. Oh, yeah, I can. Oh, and I got to figure out how to get. Okay, well, I don't got to figure out how to get it out. It just came out. So now I got the clamper off, and I'm going to see if the laser moves. Okay, so it's trying to focus. But the lens here looks really dull. I think I'm going to go ahead, I should clean that first before I do anything else. So we cleaned the lens now with alcohol. So it's got that, I don't know what that foggy tinge. Definitely got that off of there. So here's a big test. We got our Burning Spear reggae CD. Same thing, didn't make a difference at all. So there's actually a couple different ways for checking out your laser. The easiest one, which I used before, is I simply looked at the unit in a darkened room, and when you had it turned on, when it was trying to read, you could see like a little red dot here. You got to look at it from an angle. You're not supposed to look, because it is a laser, you're not supposed to look, of course, straight up and down. I think I checked it from about a foot or so away. But this one, I tried it. This one, I couldn't see anything. And of course, you can use your multimeter here to do voltage checks, and then convert that to current, so you can see how much current the laser is actually using. But that's kind of complicated, because then you got to take it like everything out to get to it. Like in this unit here, I don't even have a service manual for this. It would be like too much of a headache. And then back in the day, we used to have like little cards you could use. They were like for checking remote controls. They look like little check cards. I had one. I don't know whatever happened to it. You could use that, but of course that wouldn't tell you, for example, now what your output was, you know, from the laser. That wouldn't tell you that at all. And basically you could use this, for example, which in my opinion is, of course, this is the best way because this will tell you right away if this is a laser power meter. This will tell you right away if your laser is working and how much it's putting out. There's no figuring out stuff. There's no tearing stuff apart first. This is just the simplest way. There is one more method of checking your laser assembly. You can use an oscilloscope and check for what's called the EFM waveform or the I pattern waveform. That'll tell you if your RF chip or your laser assembly is good. But that's like in this unit here, that would be, I think, a headache of getting to that too. That's not like, a lot of times it's not feasible to do that. The easiest way, again, is to use the laser power meter here, and that tells you what's up right away. And those are around used, as far as I recall, I think around 50 bucks off of eBay. CD in there now, and I'm going to hit play. And all I get here down here is an E message, which I would say E is for error. That means it's not even reading the table of contents of the CD. If it were reading that, then I would go ahead and know, okay, the laser's working, because in order to read the table of contents, the laser's got to be working, right? So, because once the laser reads that, and then only after that, only when the laser can read everything correctly, then the motor gets the command, basically, okay, go ahead and start spinning up, which is not what this thing is doing now. So now I am going to use the easiest method here, the laser power meter. Check this out. I've got the switch here, function switch, in the diode position, and I'm putting this in the 1 milliwatt position. I looked online. I don't have the service manual for this unit, but the next model below that and the next model above, I think either one of them had the service manual, and they all seem to use the same laser assembly, and it's supposed to put out 0.4 milliwatts. So that's why I've got this now in the 1 milliwatt position. So I should be able to check this out. Of course, I have to have I can't use an overhead light on here, because what will happen is then you'll get a false reading. Because if I would turn on the light right now, the little desk lamp, the standing lamp that I'm using here, that would peg the actual needle out. So let me go ahead and do that. First, I should turn it on, and then we can see here. And once let me turn this, let me hit the play button. You can see here. We can see it's actually trying to jump up and down. It's actually trying to focus, but there's nothing for it to focus on. So let me go ahead and I get this right above this thing. Back this out, and then we'll see very fast how much this is putting this, how much power this laser is putting out. So hit the play. Okay, is it not putting out anything? Do it again. Okay, there it goes. It's on a 1 milliwatt scale. So it was putting out 0.1 milliwatt, which is like way too low. And I think it was supposed to put out 0.4 milliwatts, right? Not 4 milliwatts, but 0.4 milliwatts. So let me go ahead and turn it down now to, I'm on the 0.3 scale now, 0.3 milliwatt scale. Hit it again. Okay, and I mean it's putting out, therefore, it's putting out 0.3, it's putting out 0.15, about 0.15 milliwatts. Try it one last time. Somewhere around there, or a little bit less. It's going up, and then that's it. So my conclusion is the laser diode is bad, and it's not really worth it. You know, I might be able to get $10 for this unit after it's repaired, but I have to put like, I don't know how much. I think this laser doesn't cost that much. Then the belt is not the greatest either, so I would have to replace both the belt and the laser diode, and that's not including the labor to take this unit apart, which is not like a 5-minute job. So in conclusion, I'm just going to go ahead and save the transformer, the main board, save the screws, and then the motors, and the rest of the stuff I'm going to go ahead and basically throw it out. And that concludes this video. Thanks for watching.